let's talk about these introductions that we wrote. Um, so you guys are gonna have another chance to do this, which is fine. If you don't want to, you don't have to. Like, keep what you did. That's fine. If you want to try it again, we can try it again. So let me be a little bit clearer about like what this should sound like when I read it, right? So your IA is going to read like an essay, not like a bullet point of topics, but like a narrative, right? In your introduction, don't be like cute. Your first sentence should be like, the purpose of this this investigation is to, like analyze or conduct a statistical analysis of this variable and this variable to see if there's a relationship between them. Something like that. That should be your first sentence. Should something to that effect of like, this is what, the purpose of this thing is to see if there's a relationship between these two things. Okay? And you can pretty that up the way you want, but like the first sentence should be that. Like, don't make me look for it. Don't make the reader look for it. Like, just hit me over the head with a hammer. The rest of your sentences in like your first paragraph should contain an explanation of why this was something that was important to you, why someone else might care about it, and or why this could be important. Okay? And most of you did a little bit of that. Probably it could have all been done more thoroughly. I would say one other thing I would say to include there would be some kind of discussion as to why you should even bother doing the statistical analysis, why the answer to this question isn't just obvious, right? Like, give an example if you're talking about, Isaac was talking about like running speed and stolen bases, right? In Major League Baseball players. I think it would be helpful in his discussion there to include an explanation of why some fast players may not steal out of bases. Sports fans in the room, why might that be the case? Well, no, you're a fast player, but you might not steal out of bases. Well, maybe you're a power hitter, right? Or maybe you're batting behind the best hitter on the team. Why bother getting out when the other guy behind you is going to hit a bunch of, extra base hits? You don't need to be you don't need an extra base to score a run. You need to not get out and hope on Big Bopper behind you hits a bunch of home runs. Maybe you play, maybe the other teams, you play a lot of teams where the catcher is very good, or the pitcher has excellent pickoff moves. Like, there are other factors other than just running speed that contribute to why you might steal or not steal bases, right? Maybe it's an injury concern. Maybe you're a high injury risk player and your coach has been like, just throw away stolen bases, like it's not worth the injury risk. There's lots of reasons why a fast player might not steal out of bases, but I think that like giving some discussion in your paper as to why the relationship between your two variables isn't totally obvious. Zach, you had like weight and 40 time. And there's another example of like, well, that seems like it should be pretty obvious that the heavier you are, the slower you are. But certainly there's examples against that, right? Like there's big players that are very, very fast. And there's small players that are very slow. And you mentioned that a little bit. You could be maybe more specific. Like if you're the kicker, it's not super relevant that you're super fast. And if you're like an edge rusher, it's helpful to be very fast as well as very big. And in general, like in football, you'd want to just the biggest, fastest team possible. Like there's never a disadvantage to being faster. There's never a disadvantage to being bigger. You should see both happening, but like that's like people are people. It's not like it's a robot you're building. But like I think some discussion of that in that section of why this is important to you, why it might be important to somebody else, and then why the answer isn't like totally obvious. Why bother doing a statistical analysis if like on the surface it seems like, well, surely smarter kids get better test scores, or surely heavier players should be slower, or fill in the blank, right? So that's like so we talked about statement of task. We talked about the why part and kind of what to do more in that to cover that. Do we need to talk about what a cover page means? No, we got it. Don't put your name on it, just put your candidate code. Yeah, it was on remember when Miss Sager came in and you guys filled out that stuff and told you to take a picture of that thing with your candidate code on it because you're going to need it? That piece of paper she gave you? That's the candidate code. It's like 3 letters and 3 numbers, right? Somebody that remembers theirs. What's the example? Like JP5624 or something? JTP. Yeah. So it's like that is what it is. So I have identification of independent variables. Most of the time you guys did that. I saw very few problems with that. You could even wrap that into your first sentence statement of task of like to see if there's a relationship between this and this where this thing is the independent variable and this thing is the dependent variable. And then with your detailed plan, so for the data collection piece, I don't know that anybody did, aside from, I think Isaac said the terms random sampling. Like nobody talked about like a sampling methodology. That should be something that should be mentioned there. Even if we didn't really take a random sample, like it's kind of random. It's random enough to call it a random sample for our purposes anyways. Will you be graded down if you describe a sampling method that's not random for the person that's grading the IAs from the IB standpoint? Yeah, you will. So you should say that. You should talk about the population that you're sampling from, like high school seniors, not NDP high school seniors, because you won't have a valid chi-square test if that is your sampling population, because you're going to certainly take more than 10% of them, right? You'll fail the randomness condition for your chi-square test for independence. You need to identify all high school seniors as your population you're sampling from, so that when you talk about your chi-square test later on, you can certainly justify you've met the randomness condition because you're way less than 10% of all high school seniors with your 50 or 60 or 70 people that you end up getting for your survey. You should talk about the questions you asked. You don't need to list the survey there specifically, but like it's a random sample and it's like a voluntary response survey. So use some of the vocabulary that we've talked about when we talked about sampling. And then when you talk about the statistics you're going to do, we really need to talk about what those are going to show. So what can a scatter plot tell us? We've just been talking about this. Direction, form, and strength of the relationship between the two variables, right? Should be able to tell you if the relationship between the two variables is positive or negative. It should be able to give you some type of relationship, whether it's linear or quadratic or exponential or whatever. And then it should give you an idea of how well that data fits the form that that it most resembles, right? You should be able to get some idea, is this close or not close, just from looking at the picture, right? So that's what you'd say there for the scatter plot, what you would hope to learn by looking at the scatter plot. Next thing, it says correlation. So correlation, we're talking about which one? Pearson or Spearman? Are we going to do both? Some of you said both. Some of you didn't specify. Some of you used capital R instead of lowercase r, which is a different thing. So be careful, right? If you're talking about correlation coefficient, be specific. If it's the Pearson statistic, state that it's that. If it's the Spearman, state that it's that. If you're going to do both, state that you're doing both. And then say what you can learn from that. What will the Pearson statistic tell us? It gives you a numeric measurement of the strength of the linear relationship between your two variables, right? It tells you how close your two variables are to behaving like a direct variation, a linear relationship. What's the Spearman statistic going to tell you? It gives you a numeric measurement of how strong the positive or negative relationship is, like the increasing or decreasing relationship. Okay, so it gives you the same information in the scatter plot. It's just giving it to you quantitatively rather than visually, right? And then the chi-squared test, you should identify which chi-squared test you're doing. Which one will we be doing on two variables? Independence. So you should say chi-square test for independence. And then what is that going to show you? Whether the two variables have an independent-dependent relationship, right? And you could talk a little bit more about like what that means. But that's what we're looking for in that introduction. To do all of that is probably more like a page and a half than what a lot of us wrote. It's probably a little bit more than what we wrote because there's a lot of stuff to talk about there, right? And I just kind of outlined a little bit of what you'd want to do. Does that help give us a little bit better direction? In general, the name of the game for any kind of quantitative subject where you're writing is be specific. Like, try to be as precise and specific as you possibly can be. Okay? Like, be detailed. I know that in other subjects, like, broad strokes are good. Here, you want to be very careful about, like, overgeneralizing. I saw a lot of us use the word prove. Should not hear the word prove ever in one of these papers because you're not actually proving anything. You're providing evidence for or against, but there's no proof being done. No one's proving anything with these papers. Okay, so be careful there. Think real hard about the words could, should, and would, and make sure you're using those correctly. For the most part, you want the word could. This could be possible. You don't know that it is. Should implies that you know that this is going to happen, should happen. And if it doesn't, something is wrong. That's not what you want. You want could, like we imagine this could be the possibility. Not would, not should, but could. Do you guys feel like you have a better idea of what I'm looking for? Okay. So for your asynchronous day assignment, just be to try this again if you choose. It's not required. Pay attention to the submission document in My Notre Dame for details on how to format your file name. Some of us did that, a lot of us didn't. We just called it any old thing. But if you did it fine the first time, like just use the same file, just like take your old thing and update it or whatever. My suggestion to you is if you didn't get that, the first thing I would do is open up my old file, resave it with the proper name, and then start doing any other editing. Just like get that out of the way right away. Okay. We feel okay about what to do this at this point? Okay. I'm assuming most of us are still in the same situation as we spoke last time with our survey responses, that nothing magically has happened and we got 50 new responses or something in the 2 days that we've been in between. So what I want to talk about a little bit today is using, my suggestion would be Microsoft Word, but how to use this to input and type in equations and formulas and things into your paper. So if you have your tablet with you and it's charged up and ready to go, I'd encourage you to take that out so you can kind of follow along, so you can do the, it helps to do it as I say it. If you don't have it with you or it's not charged up or whatever, I'm recording all this so you can go back and watch it. But I want to talk about what we're going to be doing in like the mathematical processes section, right? There's four sections in your paper. So you should have an introduction, should have like a information data collection where you talk about like in more detail of how you did it. You can reference your survey specifically. You can put that survey, a copy of it in the appendix or embedded in the document straight away. Appendix is usually easier to reference. You can talk about like the number of responses. You can reference the data that you got back. Again, I would put it into an appendix item, just a list of your raw data. So that's section 2. We're not going to talk about that right now. What I want to talk about is section 3, which is the mathematical processes section. In this section is where you're going to talk in more detail about the specific type of statistics you're doing. You're going to talk about the notation involved, the formula for how to do the calculation, and then you're actually going to type in the calculation with your data. So those, and mostly what I want to talk about here is getting the symbols that we need into Microsoft Word, how to type an equation into Microsoft Word so it formats it nicely for you so that you can find the symbols that you need to write the formulas in there, that kind of stuff, right? So I'm not going to talk about what to write. I'm going to talk about like generating the symbols and the equations and kind of what this would look like in your paper. Okay? And again, I would follow along with me while I'm doing this. I would save this because the formulas that we're going to type in are the same formulas. I would just use this to either copy and paste into your other document that you've already started, or bring your stuff that you've already started into this document, whatever. But like, I would save all this because it's going to save you time later on because you won't have to do it again. Everybody's okay? Okay. So, you do your like blah, blah, blah. Next, I calculate the mean for both my independent and dependent variables, right? I denote, or probably don't use a personal pronoun here, maybe we denote the mean for the independent variable as x bar, right? So how do I type an x bar in now? So I'm going to press the insert button here at the top. I'm going to go over to the equation option here at the far right. And what this does now is it opens up the equation editor on Microsoft Word. What I want is an accent mark. So I'm going to pick that. I'm going to look at the different accent marks. And it looks like that one right there is the one with a bar above something. So I'm going to pick that one. And then I'm going to type in X in the spot. And then I'm just going to click outside of the equation editor. And then we'll keep on going. So I'll say, and then the mean for the dependent variable, we're going to denote as y bar. So again, I'll go back and I could just copy this and save myself the hassle of like clicking through all those menus, paste it in, and just go back and replace the x with a y. Is everybody okay with doing that? And then I'd say where, and then maybe a colon. And now I'm going to type in the formula for how I calculated x bar. So I'm going to, again, press the insert button at the top, or insert tab at the top, select the equation button, and I'm going to type in the formula for x bar, let's say. So I'll do accent mark, pick that one with the line above for my x. I got to move my cursor out from inside of that accent bar and press an equal sign. And what was the formula for a mean? If I looked that up in my textbook, that was the sum. So I'm going to pick from the large operators option. I want this one, where the sigma has something above it, below it, and next to it. The subscript for this would be I equals 1 to n as the top. And then I want x sub I here. So to get a subscript, I'm going to press the script button. And if I look at my options, this one is the subscript. So x sub I. Yeah, and if you need to move because you can't see what I'm doing, so you pick the script option from the equation editor. Yep. And then the one that looks like the subscript. I think it's the second option or the third option. I can't remember now. And then I might say the same thing about the y's, right? Well, show me what you got.
I think I typed in the right. Oh. I was clicking that one. Still don't like it. Okay. And then I just copy and paste it.
Yeah, do it inside the equation editor though. Hi.
Hi, I keep pressing the above and below, and it's getting me out in front. So how
Yep.
can I change this?
Yep. So this is the issue. Okay. Gotta have it. Oops. So let's do this. So put your editing marks in, because as soon as you're outside of the equation editor, you press like a space,
Yeah.
it's gonna pull it out of that format. So if you want it to like center and be big, it's gotta be the equation editor can be the only thing on that line.
Okay.
Or Word just like,
It's gonna
Mucks
go
it
to
up.
the other
Yeah.
one. Yep. Thank you, Mr. Gould.
you're welcome. Okay, what else are we gonna need? Well, before we can do chi-squared, we need something else. We need standard deviations, right? So, I should say something different in addition to standard deviation, right? How many types of standard deviation are there? 2, right? There's sample and population. We should be specific here. Which one do we mean? Who remembers? There's sample and population. Now, we talked about both of them briefly, but only one of them the IB uses, and the only one of them we've used so far. I think it's population. Let's double check here real quick. I'm just going to do a quick Google. Yes. We do the population. And what is the symbol we use for standard deviation? That's sigma, and then we're going to put a subscript on each of those for x and y to denote the difference, just like our calculator does. So I'm going to go and press the insert button now. Equation. And then this middle piece in here is what we're going to be using. So I'm going to pick the little drop down here. And I'm looking for the sigma symbol, which I see right here. Oops, but I forgot to put the subscript on it, right? Usually I pick that first. So what we can do, I'm just going to highlight the sigma and then pick the subscript, and it'll attach the subscript to it afterwards. So you can always, if you forget, you can do something like that. And oftentimes it'll take, sometimes it's like weird about stuff and doesn't want to do it for you, which is always irritating, and I can't ever figure out like why it's being stubborn. So I have that, and I'll say like where, and now I'm going to type in the formula for sigma x and sigma y respectively. Who remembers the formula for the standard deviation? You know how to do it on your calculator, which has always been enough, right? So it's 1 over n times square root of the sum I equals 1 to n of, and then I need the difference of our data points with the mean squared.
So this is like a shortcut to subscripts.
Yeah, you can use the like the bar. So like Diego, if I typed in, let me just pull up a new one. So if I do like X and then I do the bar 1 or something and press enter, tab or whatever, or space even, it'll put the subscript in there automatically. And if you do like the caret up, it'll put the superscript.
Yeah. At least like
The shortcut, the keyboard shortcut. So if I do like the down bar like that, that's like shift in the thing right next to the 0. And then I type like a 1 and press space, it'll put the subscript in there for you without having to do that. Or if I did the caret up and then press the space, it'll put the superscript in there. Most of this stuff I can do with the keyboard because I know the code that they use to write this stuff. So I update that to include my y's. I equals 1. Always going to be I equals 1. Now, before we get going further,
just select highlighter. Is that
Why did it just make it smaller?
so watch this, Alexa, or Alexis. See where my cursor is right here, outside of the equation editor? If I press space, it shrinks it. If I want that big and centered, the only thing in that line can be the equation. So like, I always have the editing marks turned on. You see this little button up here? I always have that turned on so I can see if I have like, oh, there's an extra space here. That's why the equation editor is getting screwed, why it's not looking the way I want it to. Or like, oh, look at that, I typed my equal sign outside of the equation editor. I did something stupid, like, you know, like makes it easier to catch that stuff. Okay, you figured it out? That helps, right? So before we get going too far, one thing we should be conscious of while we're doing this is that all the symbols in our formulas, we've identified what they represent. So let's look at the sum formula. We already listed x bar and y bar as the mean of our independent dependent variables. But what haven't we described yet? We don't know what n, we haven't stated what n is or what xi and yi are. So we should probably have done that before we moved on to standard deviation. So let's do that here. I'm just going to put a space and type this in. And then I'll just say end n. So I'll just yes. So n is just the number of samples, and xi and yi are the ith sample in our data set or something like that. And because I've done that here, if I look at the sigma x and sigma y, I have the same issue, right? I have x and then xi, but I've already, or n and xi and n and yi, but I've already defined what n, xi, and yi are, so I don't need to do that again, right? I just need to, I'm just going to do it once the first time they come up, and after that I don't need to keep telling the reader what these things represent. Oh, what is the rest of that? It's the Pearson product moment. Is it correlation coefficient? Is that right? Okay. So again, next thing we're doing is we needed these two values because, or the means and the standard deviations to do this Pearson calculation. So now we'll type in the formula for R. Remembers that. Let's double check that. Yeah. Do they not actually write down the formula in our textbook anywhere? That's classic. Classic IB. Who would need that, right? Who would actually want to know how you actually did something? Blah 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 blah.
So X I X bar over standard deviation of X. It's on the back of that gel.
Oh, perfect. Yeah, read it to me then, homie.
R equals 1 over n. It's not sigma. It's like the weird E looking one.
Yeah, that's sigma. That's the capital Greek letter sigma.
Parentheses xi minus x bar over standard deviation of x.
Okay, so xi minus x bar over standard deviation of x.
And then that's in brackets. Like that's the sigma.
Yep, and it's like times, and then it's the same thing with the y's, right? Okay. And then I'm just gonna do, oh, that's interesting that it did that. Ah, what a booger. There we go. And again, I don't need to define any more of the symbols here because we've already defined everything that we're using, right? We defined sigma x, sigma y, y bar, x, xi, yi, n. All those things have been defined, so we're good. There's a lot of symbols, so I'm just pausing here. But now that I'm pausing and thinking about this, I feel like like we probably would have done our mean calculation right after we defined how to do a mean. So maybe I'm going to go back and add in, like, you know, the mean for my data was, and then show how I did that calculation. So I just made up some numbers there. And I would do the same thing for y. So again, this is just Mr. Kulik making up kooky numbers. Those would be what would come from your data set. Oops, I shouldn't say my though, right? Just say the. Now notice I'm being a little bit careful here when I'm doing these, because I promise you the person that does the moderation for these papers is going to do the same thing. They're going to make sure that the data points that you're using are consistent with what you've shown in your previous calculation. So notice the first x value is 8 for both the mean and for the standard deviation. The second x value was 11 for both the mean and the standard deviation. The last x value was 2 for both the mean and the standard deviation. And I'm making sure I'm doing the same thing with the y's, right? So make sure that you're being consistent. Is this feeling okay? You feeling better about how to use this editing? Now you're gonna have to fill in some narrative around this stuff, but I just want it to work because we're not at that point because we don't have data. But like, this is something that we needed to spend some time doing at some point. We're gonna do it now, even though we don't have like your specific stuff to type in, but that's easy to update once you've got like the template in place for you, right?
How do you do the multiplication symbol?
Oh, the little dot? So if I'm in here, if I choose from the drop down, it's like right there. You could also type \bullet and then press a space and it'll put the dot in. I can never remember that though. We're just taking care of like the most tedious part of this thing right now, right? Tuesday. Yeah, today is technically your review day, but this felt like, well, at least another, like something we needed to do at some point and like run out of days to do stuff before I expect you to start writing this thing. So.
Are you gonna like tell us the format?
Yeah, I mean, it's all in the OneNote. So if I look at the very first one, I think this is probably the best one to look at. Oh, for the test. Oh, yeah. I can do that too. Yeah, we'll take a break in like 5 minutes and I'll look that stuff up. Stupid thing. It's annoying. And now I know this is supposed to come out to be a real number, but I just don't feel like typing it into my calculator right now. So I'm just gonna, kind of guess at it. Probably less than that. Oh, look at that. Little typo there. It's supposed to be a regular A, not an A bar. November cotton flower. Can't say that I have. How is it?
Not sure. I don't know what I looked it up and it was like a depression of slavery.
The depression of
No, like,
slavery?
like how the slaves were like.
Oh, oppression and slavery. Got it.
But
Oppression or oppression?
oppression. I've said it 3 times.
Everybody says it different.
And then she was like, in the beginning, this whole in the beginning, it's about
I definitely got a slave rating from it too.
Yeah.
I don't know where she was getting so.
she's getting
I don't know where that coming from. Oh, I have. But I think
So you should take it back.
and I really do not want to look outside of that.
That's the one. That's a big way to look.
All right, how do you guys feel?
I love this class.
No, I meant about what we've done so far here. Does this feel like you've gotten a little bit of a handle on how to do this?
I don't really.
Is there still more stuff to type in? Yeah, we haven't talked about chi-squared. If you're choosing to do the Pearson, or I'm sorry, the Spearman statistic, still need to talk about that. Although there's not much to say there other than like type in how you did it, because you just say like, oh, I had to rank my data and talk about how you did that, refer to your ranked data in your appendix, and then show the calculation, because it's the same calculation as the Pearson. It's just the data that you're using is different, right? It's the ranked data. And then the chi-squared statistic is the only other thing left to kind of type in, like equation about. Okay? But be careful when you're doing this stuff, that if you're referring to something and you're using the symbol, make sure you type the symbol in with the equation editor so that the formatting looks the same. If you talk about R, don't just type R. It should be the R from the equation editor so that it's italicized and uses the same font and everything else. Like, if I was grading this, I'd mark you down for writing R versus R from the equation editor, because they're two different symbols to me. So be careful about that. Worth pointing out too, if you want to type in the chi-squared, so I go equation editor, and if I look in here, chi isn't one of the Greek letters listed here. But if I take this drop down where it says basic math, and I instead pick Greek letters, I should see the chi symbol. Where are you? There you are. So I can do like chi-squared there. So it's not an X, keep in mind. If you type X, I would mark you down for that. I would not count that as proper notation. You need to use the Greek letter chi, or need to write it out, chi squared, each time you use it. But like, I would do that. The one thing equation-wise you don't need to type in how you got is the p-value from the chi-squared test. Like once you come up with your chi-squared statistic, you don't need to discuss how you get the p-value by hand, right? That doesn't need a shown calculation for. Because technically speaking, what you're doing is calculus, and that's beyond the scope of this class. If you take enough statistics classes, you'll do it by hand, but that's not what we're doing here. Okay. Should we talk about the test format? All right. Let's type that in. Oh, I still need to do that, huh?
What little like powwow is Elise at?
It's some kind of MHSA sportsmanship thing. So you have 15 total questions, 53 total points. All right, let's see. Given a best fit line and a situation, describe what the slope and y-intercept mean in context.
Okay, who gave us Thor at number?
No idea what that is.
So you should be able to discuss how changing units in your data set affects your R value. What does that do to the R value? Good. Say given means and standard deviations, write the best fit line. Feel okay there? Right, that's just your formulas that we just typed in a minute ago. Use a best fit line, oops, not FERT, fit line to make predictions. What do we have to be careful about here? Yeah. Am I going to try to trick you with that?
Yeah.
Yes, told you that before. Given a data set, you should be able to identify the independent and dependent variables. And then construct a scatter plot. And then, find the mean point. And then show the calculation for the R statistic. So the same kind of format on the quiz where I ask you to give me a couple lines out of your calculator when you do it with the lists. Should either use your calculator to get the R value and best fit line.
I think there's another book that was more than this version. But I don't know. I can't guess. Can't put my finger on it.
And then you should be able to, given a data set, to calculate the Spearman statistic. And again, you should make sure you're being careful about how you're dealing with the ties there. A lot of people had issues on the quiz. It was the most missed thing on the quiz was how you dealt with your ties when doing the Pearson, when you ranked your data. But that's about it as terms of topics that you need to be able to do. In general, this should be relatively easy, as most everything we're doing here, the calculator is going to do for you, right? It's going to either plug into a formula or the calculator is just going to do it for you. So this, when you plug it into the formula, you know if you have it right or wrong, right? Like it should be okay. The hardest thing is, again, getting transforming your data into ranked data. The data that you have for this one, it's much nicer than the other one because the data set's a lot smaller. So there's only 8 points in the data set on the test instead of like 15 or whatever, which makes it a lot easier to deal with doing the ranking. It's not quite so overwhelming. In general, though, to me, this looks like one of the easier ones that we've done conceptually, because there's not a lot to this, right? You just got to be proficient on your calculator, and you should be pretty good. Tuesday is the plan for that. So what's due problem set wise? Let's talk about that real quick. All right. Do I have anything in there yet? No. So we should have problem set 3. What should that consist of? I think that's probably just the 14.3 problems. We'll put the review in a separate problem set that doesn't have to be due this Sunday. How's that sound to you guys? Okay. So that's 1 through 8.
Judaism, Islam, all of the religions on this guy.
Ferdinand is this guy.
Mr. Gulick, tell me everything you know about the church in the Middle Ages.
Part 1.
Boy, should we start with indulgences?
Yes, the indulgences.
She had to separate it into two parts.
We had to separate it into two. Luke, name the 6 models of the church. Oh, got you there.
And like, what's even worse is, okay, just you can give me the 6 models of the church, explain what they do.
And then, on top of that, give 2 thorough examples from each other.
I mean, I'm just going to
I've been liking it.
Oh God. I remember when you said, I was like, I've never learned how to